So let's start with here. Uh, I have written -4 in another form. Okay, but the question is to find alpha, given that alpha to the power of 4 equals -4. I'm going to write in this manner: 4 times e to the power I, 2k minus 1 times pi. Alright, so now let's just start taking the square root of this guy, and it would be pretty straightforward to find the roots of alpha. So I would say, let's take the square roots. Alright, let's go. Just dive right into it. Alpha to the power 2 equals plus and minus 2. Square root of 4 is 2. E to the power, by the way, whenever you take the square root, you can remember you divide the exponent by 2. So I divided the exponent here, which was 1 by 2. So we ended up 4 to the power 1 over 2 became 2. I would do the same thing with I. E to the power I, 2k minus 1 times pi divided by 2, just because I took the square root. Okay. Now let me take the square root again, but let's write it down. You'll see how does it look like. Alpha would be equal to, okay, so I'm going to take the square root of plus 2 times this guy. So it would be plus and minus square root of 2 times e to the power I, 2k minus 1 times p divided by 4. And once I'm going to take the square root of minus 2 times that guy. So minus 1 is equal to I to the power 2. Can you remember that was the definition? So the square root of I to the power 2 is I. So I'll have plus and minus I, because of the minus 1 here, square root of 2. E to the power I times 2k minus 1 times p divided by 4. Okay, that was perfect. So we have something in here. We have something, but it doesn't look lovely. Let us do something. We have e to the power I times something. We can use the Euler's formula. All I have to do is to replace theta by 2k minus 1 times p over 4. And use this formula to write things in this manner. Then I know what is a cosine, what's the value of a cosine and a sine. That's much easier to handle. Okay, so let me do that too. Right, let's go down a little bit. Alright, so let me start from the first guy. Plus square root of 2, so I'll just put square root of 2 times, so we had Euler's formula had cosine times theta, and this guy would be theta now. Whatever is multiplied by I is theta. So cosine of 2k minus 1 times pi over 4. Right? Plus I times sine of 2k minus 1 pi over 4. Okay? That was about it. That was the first guy. That was the first guy up here, the plus this. I should do the same thing for minus 1 plus minus 1 and write out exactly the same thing, but I'm just going to do one of them and you can do the rest. I'll give you the answer and you can do the rest and figure out that the answer is actually correct. So let's see. What is the cosine of pi over 2 times, I don't know, 1, 2, 3, 4, whatever it is, because this thing would be essentially 1, 2, 3, sorry, it would be 1, 3, 5, and blah, blah, blah. So cosine of pi over 4 is square root of 2 divided by 2. But cosine of 3 times pi over 4 is minus that value. So it just goes from minus 1 to plus 1 all the time. So this fellow in here would become plus and minus square root of 2 divided by 2. The same story is valid for sine. So this guy is also plus and minus square root of 2 divided by 2. Now, look how convenient. If you multiply square root of 2 by the denominators, we can cancel out with the denominators and we'll end up with, I'll just write out, plus and minus 1 plus I. Alright, so we have I, they will have 1 here, they will have I times 1, and we have a plus and a minus, so I'll put it on the other side. Okay, you can do exactly the same thing for the rest of the guys in here, the minus, the plus, and minus, and you will essentially find 4 unique answers to alpha. So alpha 1, there are 4 of them, so alpha 1 would be equal to, for instance, 1 plus I. Alpha 2 would become minus 1 plus I. Alpha 3 becomes minus 1 plus I, and alpha 4, 1 minus I. Okay, so that would be the 4 alphas. You can test that and you can power each one of these alpha to the 4, and you will see that you will end up with minus 4. Okay, so we needed that to move on to the next differential equation.